All right, hey everyone. My name is Krzysztof, and I'm super excited to be here today with you. I work as a developer tools researcher at GitHub Next, and I have two confessions to make before we go further. First of all, despite the name of the conference, my talk has 0 JavaScript in it, so sorry about that. Okay, I will remember that. And the second confession is that I'll be talking quite a bit about artificial intelligence. And I don't really know much about artificial intelligence. I'm not data scientist. I'm not machine learning specialist. But I do hope that most of you are also neither of those. So hopefully we can find some common ground here. And yes, there will be some QR codes on my slides. I've thought that I'm really smart that I'm using QR codes, but so far everyone has been using QR codes, so yeah. There will be mostly some additional reading, additional information about some topics covered on the slides. Obviously in 25 minutes I cannot cover everything. This one is the most important one. It goes to my Twitter account. You can follow me there. So I work at the organization called GitHub Next, and we are part of the GitHub that is responsible for investigating the future of software development. Basically, we're a group of researchers and developers that prototypes tools and technologies that tries to push boundaries of what we thought is possible with the software development, and also go where no one has really ever gone before, well, at least in context of editor tooling or software tooling. You can find more information about team and our projects in the web page under the link. However, today I want to talk about our most well-known and most successful project, which is GitHub Copilot. So you probably have heard something about GitHub Copilot before. There has been quite a lot of buzz in the internet about it, on the social media, you know, Reddit, Hacker News, all the usual places. But still, let me give you a quick introduction to GitHub Copilot. Basically, you can think about GitHub Copilot as more powerful autocomplete tool. However, unlike traditional autocomplete tools, it is not powered by the semantic information or static code analysis. It is powered by collective knowledge of all software developers, AI model that has been trained on the billions of lines of publicly available source code. Unlike traditional autocomplete, it is not limited to suggesting you a single word. So traditional autocomplete suggests you function name or variable name. GitHub Copilot is capable of suggesting whole lines of code or even multi-lines blocks of code that adapt to current context of what you're working on and adapt to your coding style. Because of that, because there is this long suggestions, we had to also come up with a totally different user experience than traditional autocomplete, which is something that I hope to cover later in the talk. And now, if you haven't seen Copilot yet, let me quickly play a short video. There will be, in a moment, you will see this like ghost text, gray text, or this thingy. Those are suggestions coming from Copilot. As you can see, they're showing in the editor as you type. They're always there. You can see them. They try to predict, the model tries to predict what will be the next thing that you will do. Unfortunately, this demo only shows like single lines, but trust me, there are also like multi-line suggestions possible. Copilot has been released for technical preview in the late June last year. And in June this year, it has been released as a full-fledged product on GitHub. So it has been used by thousands and thousands of developers. It has been tested and all that jazz. But still, you probably want to ask me, yeah, this looks like a cool demo, but does it really work in practice, this like magical Copilot thingy? So I have a bunch of numbers to kind of convince you that hopefully it works. So for users that have Copilot enabled on their files, 35% of newly written code in those files where Copilot is enabled is being suggested by GitHub Copilot. We have kind of advanced telemetry where we track whether you accepted suggestions, what changes you've made to the suggestions, so we can see what is percentage of suggestions that were successful and what you change and stuff like that. So this is really nice number. It's already fairly impressive, at least I believe so. However, the most important thing about this number is that it has been steadily growing since day zero. And we believe that we will be able to reach, in a couple of years, way higher level. However, this number doesn't tell us whole story. Yes, this maybe tells you that, okay, some code was generated, but it doesn't really tell us anything about how developers feel. And this is the most important thing when you work on the developer tools. 88% of developers feel more productive when they are using GitHub Copilot. This is coming from the actual user research that we've conducted. Again, QR code goes to the blog post where everything is described. We performed the user study, which included survey of over 2,000 developers. Around 60% of those were professional developers, 30% were students, and 10% were hobbyists, so it kind of like was a view of the community in general. And this is based on their answers. So people just feel productive when they use Copilot. And also, developers feel that they can focus on more satisfying, more important, more creative parts of the coding when they are using GitHub Copilot. So Copilot is really great at generating and automating writing of this like boring lines of boilerplate code that sometimes we all need to write. It's really great at those repetitive tasks. Maybe at generating unit tests, it's pretty decent. So the boring stuff that we don't really want to do. We want to, as a developers, we want to focus on interesting stuff, on the stuff where our intelligence and creativity is needed. That's why we are getting paid quite a lot of money. So yeah, so that was hopefully this general overview trying to convince you that Copilot is a decent tool and you should try to use it. But let's now move to some technical details. Because I'm a software developer, I want to talk about technical details. So initially, when I've joined the team and when we started Copilot, we had this really complicated architecture. We had Visual Studio Code extension that was containing all the logic. And then we had AI model was hosted by OpenAI on their servers. So that worked great. It allowed us to quickly iterate and improve the project, prototype stuff. But then we released the technical preview and we got users. And probably, as we all know, when there are users, there are problems. So our users started to ask, what about IntelliJ? Or what about NeoVim? What about Visual Studio? Okay, no one has asked about Visual Studio. I'm joking. Also, people have been asking questions like, why in some geographical location Copilot is so much slower than in others? And obviously, we had the super simple architecture models hosted in one or two places. Okay, that's like latency and all that jazz. That was kind of like difficult. So as we scaled with the number of users, as we scaled number of IDEs that we supported, as we scaled number of developers in our team, we had to change stuff a bit. So nowadays it looks something like that, more or less. It's really high level of overview. We have support for multiple editors. Visual Studio Code is still our main extension and our main IDE, probably the most popular of the ones that we support. But we also added support for a whole suite of IntelliJ IDEs, so PyCharm and all the Ruby IDE that I don't remember, what's the name, Rider, and all the stuff from JetBrains is supported. We added support for NeoVim, and yes, we had to also add support for Visual Studio. And then when we decided to do all those editors, we kind of realized that we don't want to replicate all the logic that we had in Visual Studio Code. It was written in TypeScript. And obviously, all those editors use different languages for their extension system. In case of IntelliJ, this is JVM and languages like Java or Kotlin. In case of Visual Studio, it is C#. And in case of NeoVim, it's some like dark magic. So we realized that this is the same problem that vendors of language-specific editor tooling hits fairly often. So for example, if you want to create a language tooling for Rust, you don't want to, again, implement the logic in all those languages, in all those different ecosystems. You want to have the single common place. And the pattern that those language tooling uses is called language servers. So we created something like language server. We call it agent. Agent is a standalone process running on your machine locally. It's written in TypeScript, so it's running on Node. Okay, I was lying about Node JavaScript, right? There is TypeScript mentioned here. So the boos that were coming from there, so. All right. It is containing all the common logic that we had before in Visual Studio Code extension. It is responsible for things like preparing the requests that we send to the model. It is responsible for things like authentication, authorization, for communication with editors. And then with this architecture, the editor side of things, plugins for all those editors are just thin clients containing really minimal logic. In case of like technical details, agent is using something called language server protocol. If you've heard about that, that's kind of like popular thing nowadays in editor tooling. If you haven't heard about that, it's basically passing JSON messages across standard input-output, so nothing super fancy. Agent communicates with proxy, which is another place where some of the common logic lives. However, proxy lives in the cloud, as close as possible to the AI models. It communicates with github.com and GitHub APIs to make sure that you've paid for Copilot, to make sure that you have access, to make sure that you don't do anything weird with Copilot. And it also communicates with AI hosted on Azure this time, which is globally distributed, so that's really nice. Proxy is also responsible for things like post-processing responses from the AI, or for adding AI safety and responsibility features, which is really, really important for us. So yeah, so now let's move to the AI side of things. We are using the model called Codex, and Codex. What are my notes? There are no notes. Jesus, that will be terrible. Codex is a large language processing model, artificial intelligence model, based on GPT-3, developed by OpenAI, or something like that. That doesn't tell anyone anything useful. So let's try to slowly go through that. It is natural language processing model, so it operates on plain text. It doesn't understand any fancy ways of encoding code, like, for example, abstract syntax tree. It doesn't understand that. You just send code to it as a plain text, as a string. And we call this thing that we send to the model a prompt. It is artificial intelligence model, which basically means that it is probabilistic model. We send it prompt, and it tries to figure out what's the most probable next word in the text that we've sent to it. Most probable doesn't mean correct, and most probable doesn't mean that it will be the same word every time you send exactly the same prompt. Which brings us to a really interesting point. We cannot really observe the results of changes that we do to the prompts easily. We need to observe them at scale. We cannot write unit tests saying, okay, there is the single input and it will give you always the single output, the same output. We cannot do anything like that. We need to observe results at huge scale of thousands and millions of responses to judge whether the changes that we do to the model are correct. This has been really weird for me. I come from traditional software development background. I'm used to, okay, I will write unit tests and then it will pass and then it will be cool. Working with those AI models is a bit different, and it definitely required getting used to. It is large language model. It has been trained on the billions of lines of code, which is cool. It means that it is really smart. However, it also means that we don't have an easy way to understand what's going on under the hood. We don't have an easy way to see why it came up with some of the suggestions. And also, as I've mentioned, it has been based on GPT-3. GPT-3 is similar large language artificial intelligence model. However, it has been trained on the whole internet, basically. So tons of English text and other language text, which means that Codex not only understands code, but it also understands natural language, which is super useful because it can understand comments that you make in your code and stuff like that. The most important thing about working with those models is preparing the requests that you will send to it. Those are just strings. The process of preparing those strings is called prompt crafting. It's a fancy name for string concatenation. So initially, we've started with really simple approach. We took your cursor position in the editor. We took the content on the file from the top of the file to the cursor position. We asked what should come next. And that was working decently well, surprisingly well, given how simple this method was. However, we knew we could do better. And again, in general, when working with those large language models, those artificial intelligence models, the more context you can put, the more useful context you can put into the prompts, the better will be the results. That's kind of like rule of thumb. However, there are also drawbacks. The more content you put into the context, the more expensive is processing. So the longer it takes and the more expensive it is. So the first improvement that we've made was fairly simple. We put the relative path of the file and then language marker. So model now knows that you are using JavaScript. It turns out that if your file is in the test folder, the model will understand that and it will be more likely to produce test cases for your file. It turns out that if your file is in components folder and your language is JSX, it will be more likely to produce some React component. So that was really nice improvement, really small improvement, but really, really nice with just small amount of changes. The next thing was, the next big problem, you probably has noticed that from my first point, is including the code that's below the cursor position, right? In most vast majority of programming languages, the order of function doesn't matter. The order of classes doesn't really matter in your file. So we had to come up with some strategy to include also the useful code that's below the cursor. So we basically detect sibling functions. So those are the functions that are on the same level as the function that you're currently working on. So for example, if you are inside the member of the class, those will be other members of the same class. If you're in the module and you're working on some function in the module, those will be the other functions from the same module. So we take all those sibling functions and then we reorder the stuff. So we put the sibling functions that are below cursor position also into the prompt. So hopefully the model will have more context. But still, we knew that we can do better. In software development, in like big projects, we have a lot of files. We don't work in single file. We have a lot of files in the project. So we decided that we also want to look into other open files in editor. And this is important part, like we don't look at random files lying on your machine or stuff like that. We only have access to the files that are already open in your editor. So hopefully those will be the files that, okay, like I mean, software development tooling is working on the stuff that you have open in editor, so it makes sense to use those files. And then we look for the code that looks similar to what you're working on right now, and we also include that in prompt. This means that if you, for example, are writing React component, and you have certain structure that you're using for writing React component or a certain naming convention that's in another file already, it's likely that we will find this file and we will put that in prompt, so the model will be more likely to produce code adapted to your style. And will have also context from all those other files, so it will know what helper functions you use in those other files. So maybe it will try to use the same helper functions. And other side of equation, so that was preparing the inputs, and other side of equations is observing results. As I've mentioned, we cannot really do that on single cases. We cannot write unit tests. We cannot really judge the correctness of our changes based on some small sample size. We need to do that at scale. And this is like two-stage process. We have offline evaluation tool, which clones thousands of repositories from GitHub that we know that haven't been used in the training for the training of the model. So we know that model hasn't seen those repositories. Then we find in those repositories all functions that have test coverage. We remove the body of the function. We regenerate the function body again with the Copilot, and we try to run the same tests to see whether the tests were passing or failing before and after to compare. This is some metric. I'm not trying to tell you that this is like 100% accurate metric of making improvements to the system like that. But at least it gives us some information whether the changes that we are making are going into the right direction or not. And the second, more important part of the observing results is just deploying change to production and observing the telemetry. And we are not almost never deploy the change to 100% users at the time. We have fairly complicated A/B experiment framework that we use to, well, we deploy the change to the 1% of the users, and then we compare all the key metrics that we've identified. And speaking about that, we've published, well, my colleagues have published really nice white paper about telemetry. I cannot really go into details right now about that because it's like long white paper that it was presented at the conference. Whole talk was just about this white paper. So, and I have 2 minutes left, so I don't think I will be able to talk more about that. The last thing I want to talk about that's kind of like close to my heart is user experience design of the Copilot. As I've mentioned, we have this different user experience than traditional autocomplete tools. This user experience didn't really exist before we started to use it. Nowadays, there are some other tools that are also using the same user experience, which I'm really, really happy about. But yeah, we've made a couple of big assumptions when we were designing the user experience for Copilot. First of all, Copilot is about enhancing your abilities. It's not about replacing software developer. Software developer, user, is always in control. That's why Copilot is integrated with this like most inner development loop that you can think about. It's integrated with how you type. As you type, the suggestions are coming. As you type, the suggestions are adapting to what you're doing. They are always there. You can very easily accept them, or if the suggestion is wrong, and this is the third really big assumption, if the suggestion is wrong, there is no cost in terms of actions that you need to take. You just keep typing your code. This means that it kind of tries to reduce the overhead of wrong suggestions because, let's be fair, those models will never be 100% correct, at least not at the current state of the art. So yeah, so it is very important for us to make sure that we don't cause, it is important for us to make sure that you are still in the flow when using Copilot. And actually in the user study that I've mentioned before, one of the questions was how developers feel about staying in flow while using Copilot, and vast majority of developers answered that they feel that they stay in flow easier when using Copilot, mostly because Copilot reduces the amount of context switching that you need to do. You don't need to go to some Google, some documentation. You don't need to look for the syntax that you forgot because the suggestion hopefully will be here. All right, and that will be all that I had for today. Thank you for watching. I hope you enjoyed that, and I really wish you a nice conference, hopefully with more JavaScript-related talks. And now I think it's time for Q&A. Do we have time for Q&A? Yeah. What do I need to do to? No? Find some good questions and read them.
You can choose, I don't know.
Okay. If I open my environment file, is the file content sent to your server along with all secret keys? Yes, unfortunately, yes. However, I would like to mention that, for example, if you have any plugin in your IDE installed, it can also do some weird stuff with your environment file. So it's all about trust, and I believe that GitHub is a fairly, it's an organization that people trust in general. So, is it free? No, unfortunately. So it is free for students, teachers, and open source contributors, like verified open source contributors, whatever it means. I don't really know. For all rest of the people, unfortunately, there is a license right now. Well, there is a fee that you need to pay for that. So it's not super expensive. Any other questions?
Yeah. Just cautious of time.
Yep. Will we lose our jobs eventually? I hope not, because that would be really stupid of me to automate myself out of the job. No, but seriously, as I've mentioned, one of the most important things about Copilot is that, and its core principle of our design, developer is always in control, and developer is always in loop, and developer always needs to make final decisions. We hope that Copilot can help you to be more productive and more happy as a developers. However, human creativity and human intelligence will always be required for the most interesting, difficult, and satisfying for us tasks. So hopefully not. Don't quote me when Skynet comes. Okay, Copilot, what is done to prevent vulnerable code suggestions? Example, malicious code or bad practices. The same that is done to prevent you to copy-paste malicious code from Stack Overflow, which means nothing. We do recommend that you still follow all the best practices that you have for reviewing the code, for maybe using some scanners that looks for malicious code and stuff like that. There is nothing built in Copilot itself, but there are existing solutions on the market that tries to help you with that problem. And also, again, software developer is always in the control. So you need to treat the code that was, that you accepted as code that you would have written. So review it in normal review process, in a normal pull request review process, please. 2 minutes. Okay, yeah, that goes well.
GitHub Copilot, and they send the data.
GitHub Copilot, I understand that data is being processed online. How does this work with code confidentiality? Wow. This is a really great question. So yes, the code is processed online. Those are large language models. They required whole racks of GPUs to run. It's not possible to run them on your local machine. So if you would be using Copilot, in your profile settings, there is an option that will tell us to, if you enable it, that will tell us to remove all the code that you've sent to us after the suggestion was generated. So again, you kind of, I guess, trust, if you're using GitHub Copilot, you trust GitHub that we will follow the option that you've chosen. If you don't care so much about privacy, you can allow us to use the code that you're sent to us for training purposes. But that's like optional. Last one. Okay, one more question. Who is the owner of generated code? You are the owner of generated code, just like with any other tool that suggests you the code. All right, so that would be it for today. Thank you again. Hope you've enjoyed that, and see you. I'll be around. If you have any questions, feel free to find me and chat, and enjoy the conference. Thank you.